This is an example of detecting the EGFRvIII mutation in glioblastoma through a quantitative within-patient self-normalized peritumoral perfusion heterogeneity measure. To estimate the EGFRvIII surrogate index, we need to load a T2 flare, a post-contrast T1, and a perfusion volume, specifically a dynamic susceptibility contrast volume. Once we load the input images, we go into the Drawing tab of CaPTk and annotate two regions, one near and another far from the enhancing tumor, but still within the peritumoral edema, depicted by the hyperintense abnormal flare signal, to evaluate the peritumoral heterogeneity of the perfusion signal. For this example, we are loading pre-annotated regions. For the near region, shown in red, we use the T1 post-contrast image to draw the region adjacent to the tumor, and we do this for multiple slices. We then need to visualize the T2 flare image to confirm that the near region is within the edema and correct for voxels that are not in this region. Then we draw the far region by using label 2, shown in green, again in multiple slices. We then go to Applications and click on the glioblastoma EGFRvIII surrogate index. The analysis takes a fraction of a second, and then a pop-up window with the results appears. On top, we see the value of the peritumoral heterogeneity index, or otherwise Phi. Based on our cross-validated analysis of 142 scans from the Hospital of the University of Pennsylvania, but also using an independent replication cohort of 78 scans, we have identified the threshold of 0.1377, shown at the bottom of the pop-up, where any value of Phi lower than this threshold should indicate an EGFRvIII positive tumor. Just below, we see the ratio of the peak height in the near region over that of the far region, which should be larger than 1, implying that the near region shows larger vascularization than the far region. We have added this to inform the user in case of a smaller than 1 ratio to confirm correctness of the annotated regions. Finally, this window shows the number of voxels actually used in the analysis compared to the number of voxels we annotated for each region. This is here as an error handling routine to inform the user if the perfusion scan did not include any data for the annotated regions.